This is Math Counts. We're doing the homework for 8/26. It was a Wednesday. Today we went over the story of Carl Friedrich Gauss. Remember that this exact problem was the problem that he did when he was an elementary schooler. He had about less than a minute to add up all of these numbers, and he did it in a few seconds. And we discovered that this is the way that you do it. You do the quantity of numbers times the first plus last number divided by 2. Let me go ahead and rederive that formula in number 2. I'll jump back into number 1 to show you how to do it, and I'll show you 3, 4, and 5 as well. Thanks for tuning in. All right. In number 1, this is how Carl saw it. Mr. Gauss, maybe. 1 plus 100 is 101. 2 plus 99 is also 101. 3 plus 98 is also 101. No matter what you do, when you add the first and the last number, you make all of these pairs that all add up to the same number. So that's where this first plus last comes from. We're adding up the first and last term to get the 101. So let me go ahead and write up here. This quantity right here is the 101. So why are you multiplying it by quantity and then dividing it by 2? Because the question is, how many of these 101s are there? Well, you have to count up how many numbers there were, and there's a bunch that are hidden in here that I didn't want to write out all the way. But I know that if I take all of these numbers and divide it by 2, in this case 100 divided by 2, or the quantity divided by 2, then that will tell you how many pairs there are. In this case, there are 50 pairs of 101 because 100 divided by 2 is 50. So this is what Carl Friedrich Gauss saw. He said, oh, I need to do 101 times 50. Ugh, that's garbage though, because I don't want to multiply by 50. I'm just going to hold on to that 0 and eat it for dessert later. I really want to do 101 times 5, and then we'll add on the 0 at the very end. So 101 times 5, 5 times 1, and I can do laser pointer here. 5 times 1 is 5, 5 times 0 is 0, and 5 times 1 is 5 again. Remember what we're going to have for dessert? That 0 at the very end, and you come back over here and you say 5,050 for our final answer. That was the answer that Carl Friedrich Gauss got, and it annoyed his teacher that he was so smart. So let's practice using this formula again and again. The way that we think about this problem is we first do first plus last. 1 plus 8, we remember that's 9. We multiply that by the quantity of numbers. How many do we have? Because we started at 1, we do 8 numbers. There are 8 quantities. And that will get a little bit tricky later, but right now, if you start at 1, the last number is the quantity. It is the quantity and both the last number in this sense. So there are a total of 8 of those numbers, and we are going to divide by 2. And I know that maybe for the elementary schoolers, this way of dividing things, this fractiony way, is maybe new to us. Maybe you're used to, oh, dividing by is this symbol. This is also a way to say divided by. With order of operations, it doesn't matter if you divide by 2 or multiply first here. You can choose which one to divide by first. We typically divide first instead of multiply by first. Yes, I know, you all know 8 times 9 is 72, and you can divide 72 in your heads. But it's much easier to make smaller numbers first. Do 8 divided by 2 first, and then it's much easier to multiply those smaller numbers rather than these larger numbers, especially when we see huge numbers like this. So let's go ahead and try it. I'm first going to do 8 divided by 2. And the way that I show my work is I say 8 divided by 2, and I do a line through and say that turns into a 4. I'm going to rewrite the problem now. Now I have 4, and then I still have that times 9. And 4 times 9 is 36. If you don't trust me, go ahead and grab a calculator, or maybe you can just do this mental math and add these all up, and you can see that it does add up to 36. So I know that there's some students that maybe didn't get it the first time, or you didn't make the meeting, or maybe you're just a parent and you're curious, what happens if you have an odd number? When you have an odd number, you have a leftover in the middle, and that leftover in the middle will still let you divide by 2 and still have a decimal. You can have an odd number of pairs, or a decimal number of pairs. I understand that this is going way beyond the video scope, but really what's happening here, let me give you an example. If I have 1 plus 2 plus 3 plus 4 plus 5. Well, how many pairs are there here? Because again, you're supposed to do, and this is not a problem that I gave you, but I just want to clarify. This is just for an example. 1 plus 5 is 6. 2 plus 4 is 6. And then I have 3 in the middle, and he's sad. He has no friends. He's all by himself. How many pairs do we have? We have 2. Oh, we have 2 pairs. So we have 2 pairs, and we are going to do 2 times 6. But that's not the answer because we have to add in a 3. Well, 3 is the half of a pair. This middle number will always be half of this number, which means we can really say that there's not 2 pairs, but 2.5 pairs. 2.5 pairs. And if I do 2.5 times 6, you can do it on a calculator, or you can remember 2.5 times 6 like this. And you can say, okay, 6 times 5, and do laser pointer. 6 times 5 is 30. And then you can say 6 times 2 is 12, 13, 14, 15. 15, and then 1 decimal place, no decimal place, so I add 1 decimal place here, and I say, the answer is 15.0, or just 15, which you could have gotten with the formula. Look, the formula would have worked as well because you have 2.5 pairs. Watch what I'm doing up here. I'm always adding first plus last. I'm adding 5 plus 1 as my first step, and I already did that. It's 6, right? So I know that this term right here is 6, so I'm going to say quantity times 6 divided by 2. That's where I'm at. I know that the first plus the last is the 6. How many pairs do I have? The quantity divided by 2 is asking the question, how many number of pairs, right? Well, I have 1, 2.5 pairs. Or you could say it's the quantity of numbers. There's 1, 2, 3, 4, 5 pairs. And you can say, well, this quantity, I can cross it off and say that there are 5 of those numbers. 5 divided by 2 is 2.5 pairs. But you don't have to do it that way. You don't have to do 5 divided by 2 is 2.5, but you can instead do 6 divided by 2. You can choose which numbers to divide. You can only do it once. 6 divided by 2 in this case would be 3. 6 divided by 2 is 3. And you're left with 5 times 3, which is still 15, just like we found down here. And you can add them all up. So I'm just proving to you it works with odd numbers because you have a pair and a half. You have a half pair in the center. All right, so I've gone very overboard on a problem that I didn't even assign, but I just wanted to reiterate. It doesn't matter if you have an even number or an odd number. This formula works no matter what. All right, let's try another one in number 3. Again, you're always thinking, if I'm adding consecutive numbers, I'm pairing up the first and the last, pairing up the second and the second and last, and they all add up to 51. They all add up to 51. They all add up to 51. And then you ask, how many pairs of 51 do I have? I'm going to have 51. I'm going to multiply by the number of pairs. In this case, because I started at 1, I can say, there are a total of 50 numbers. So I can multiply, or I can divide that by 2 and say there's a total of 25 pairs, 25 pairs. If I want to use just the formula and plug in the formula, you can do that as well. You can say, well, the formula says that the sum of the numbers is equal to the quantity times the first plus the last, all divided by 2, and we can substitute in here, right? We can say that the first number is 1, the last number is 50. The quantity in this case happens to be the same as the last number. It's also 50, and we're still divided by 2. Let me rewrite all these numbers down below. I have 50 times 51, all divided by 2. And you get to choose. Do you want to do 51 divided by 2? Ugh, gross, decimals, right? I don't want to do that. Or do you want to do 50 divided by 2, which is much more satisfying? Yes, you want to do the 50 divided by 2. 50 divided by 2 is 25. And you're left with 25 times 51. Again, just plugging and chugging into the formula. 25 times 51 is what we're trying to do over here. So 25 times 51, what are you? There isn't a really good shortcut to this. I can show another way of multiplying that you might have never seen before, just teaching some new things in this video. But usually the most common way of doing this is you say 5 times 1 is 5. 5 times 5 is 25. And now that we're moving on to the tens digit, we have a 0 here to say we're multiplying everything by 10. This is really 20 times 1. That's why we have the 0. So we say 2 times 1 is 2, no carrying. And we say 2 times 5 is 10. And then we can add these together and we can say 5 plus 0 is 5. 5 plus 2 is 7. 2 plus 0 is 2. And then we have the 1. So it's 1,275. That's our final answer. Much, much quicker than adding these manually one at a time, especially when we get really large numbers. All right, in number 4, we get a bit weird. So I really like using the formula, relying on the formula, but you can use logic too. Let's do it both ways. I'm going to first start with logic. Logically, I know that Carl Friedrich Gauss made pairs. He did first plus last to get 16. And just to verify, I can do 2 more. 3 and 13, yep, that's still 16. 4 and 12, yep, that's still 16. Okay, there's all of these 16. So how many times 16s? How many pairs of 16s do we have? Well, that's a little bit harder because I can't just say that there are 14 of them. I didn't start at 1. I started at 2. So if you thought the answer was 14, it's actually 1 less because we didn't have a plus 1. We actually have 13 numbers. And if you want to write all of those numbers out to re-verify that, you can. Is there a quick way to find quantity? Yes, yes there is. And I don't mean to overly rely on formulas, but in general, quantity is really important because it's part of our formula, right? I said quantity up here. Sometimes it's a hard number to find, but quantity is always going to be found by doing the first, no, I'm gonna do this backwards, sorry. It's the last minus the first. That was too big of an eraser, Mr. Sindel. There's a better sized eraser. It's the last minus the first divided by, what's a good way to say we are adding one? We are adding one. We are adding one. By, I guess, how it's changed, I'm going to go ahead and define this as the change. If you want to know the Greek letter for change, it's this capital delta symbol. It's just a triangle. I'm just going to say change, divided by the amount that you change. For example, if I'm changing by adding by 2, adding by 2, adding by 2, adding by 2, I would divide by 2 down here. Usually speaking, we only add by 1, add by 1, add by 1. So we divide by 1, and dividing by 1 is the same as not worrying about the change, right? This will be important in the question number 5. So how many do we have? Well, I'm going to use the formula. Oh, and I think I've messed up. Have I messed up? Let's go ahead and see. Because I don't think this works. Look, I know the answer to this one. It should be 13, because 1 less than 14, because I moved out the 1. So it should be 13. I don't think this formula works. 13, let's see. 14 minus 2 is 12. I forgot to do the plus 1. Yeah, that is my mistake. I knew in the back of my mind something felt off. You do have to have a plus 1 to account that you're subtracting a little bit too much. Every single time, we always add 1. Let's see if that actually works over here. Remember this quantity? We had 50. Let's see if we get this. What do? We did 50 minus 1, which is 49, and then you always add 1. 49 plus 1 is 50, so that quantity works. Let's check up here. To find the quantity, we knew that the quantity was 50, well, I guess it's 100 of these, and then we divided by 2 to get 50. But the quantity should have been 100. Again, it's last minus the first. 100 minus 1 is 99, and then you always add 1, so there's a total of 1. Let's check over here. How many do we have? We have 8 minus the 1, which is 7, plus 1, and we had a quantity of 8. That was the quantity right here. Okay, so that formula does work. I've re-verified it. From here, we can just make sure 14 minus 2 is 12, plus 1 is 13. So there are a total of 13 for our quantity, and then we always divide by 2 for our formula, or you can think about this as there are 13 divided by 2 numbers of pairs, right? All right, so from here, we can choose. Do we want to do 13 divided by 2? Ugh, gross. Dividing by 2 with an odd number? No, we don't want to do that. What about 16 divided by 2? Yes, much nicer, right? 16 divided by 2 is 8. And then we just have to do 13 times 8. So let's go ahead and do 13 times 8. Again, 8 times 3, 24, 24. And then 8 times 1 is 8, 9, 10, 104. Very nice. And then we move on to the magnet challenge. There are a lot of ways to approach this one, guys. So I'm going to show you my favorite way. It's a really advanced trick. So if you're watching this video, you're learning something brand new that's going to be super useful throughout college level. If every single number here can be divided by a number, divide it by that number and do it at the end. So, for example, 2 can be divided by 2. 4 can be divided by 2. 6 can be divided by 2. Every single one of these numbers can be divided by 2. We're going to save that number for dessert. So, if I divide them all by 2, I really have 1 plus 2 plus 3 plus 4 plus 5. You guys see what I'm doing? 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. 10 divided by 2 is 5. Now I'm copying down this part. Plus dot, dot, dot. Plus, technically it's called an ellipses. And then we do 46 divided by 2 is 23. Plus 48 divided by 2 is 24. Plus 50 divided by 2 is 25. What do? At the very end, for dessert, we will multiply by 2. There's our dessert. We'll multiply by 2 at the very end instead of the very beginning. Now I know how to do this problem. The way that I do that problem is I do first plus last, right? First plus last is 26. Just re-verify it. 2 plus 24, that's 26. So I'm going to multiply. How many 26s do I have? I have a total of, well, I do first minus the last. 25 minus 1 is 24, and then I add 1, so there's 25. There's 25. Oh, I didn't have to do that in pen. 25 of those 26s, and then we always divide by 2 for our formula. But here's the thing. We also, for dessert, have to multiply by 2. Multiply by 2 for our dessert. And guess what? When we have the same number on the top and the same number on the bottom, if we're multiplying by 2 and dividing by 2, we're undoing each other. We can cross these off. It's called cross-canceling. We don't have to do them. And then we just have to do 25 times 26, and we're done. This is going to be 25 times 26. What is that? 25 times 26? Let's see. 6 times 5 is 30. 6 times 2 is 12, 13, 14, 15. 15. We're multiplying by our 10, so there's our 0. 2 times 5 is 10. 10. And then 2 times 2 is 4. 5. And then we add them together, we get 650. I might have made mistakes. I made these problems up on the fly, but that's how I solved each of these problems. There is another way to solve this problem using this quantity number and still using the formula. I don't have time to get into that, but maybe we can talk about it at our next Math Counts meeting. Thanks for watching.